Basically, chatbot template will help us to standardize and structure the way how we talk to an AI. When I say standardize and structure, it helps us in providing the rules, context, scope, and what AI should return to us. We can use this to import the chatbot template. So let me go back to the code, and I will be defining a function, call it as input user input formatter. Okay. And basically, the syntax of chat prompt template will be mostly like a tuple with system tbd. That's to be updated. Okay, tbu. And user, it will be user message. Now, I want to tell an LLM basically that you are an intent extraction expert. Your job is only to identify the user message and then specify what social media platforms user want to post. And also, I want it to return me in a specific format. Okay. Like a JSON format where the key as the platform name and the value either true or false. So this is what I'm expecting. So I will be providing the same text to chat prompt template, and later this we will be passing it to the LLM. Okay. Let me define a variable here. Okay. So basically, this is what I will be passing it to the LLM. I will copy the system prompt and I'll populate it here. Okay. And I want this to be dynamic. So it will be picked during runtime or basically during the execution itself. So we have created the so it is saying that the syntax warning tuple object is not callable. Yes, because we have missed a comma here. Let me rerun this. Okay, we are good. Now, what I'll be doing, I'll be calling our LLM. Okay. Basically, to call an LLM, there are three possible ways in LangChain. So one way of calling is directly we can use the model provider. Okay. Like using from LangChain underscore grok, import chat grok, and then use LLM equal to the model provider name and pass the parameters. Okay. The other way of calling LLM is using init chat model or create agent. So as I mentioned earlier, I'll try to also cover create agent, but let's use chat init model for now. Okay. So it is saying that, so basically the installation is required. See the model provider parameter below for the specific package name. Example, if you want to use an OpenAI, you need to install the OpenAI package. We are using Grok. I have installed the Grok package already, so we don't need to worry about that. I'll just copy the syntax from here. I'll paste it. Okay. And then I'll use this line of code to call our LLM. So here I'll call it as a input intent analyst. So I'll be calling this function name as intent analyst, and basically I'll be calling. Okay, sorry, I did forgot to do one thing here. So we need to return this function. So I'll be using same not when three. Let me check if we have any models available. So I'll use llama. So I'll use the llama 3.1 8B instant, and I'll execute this. Right now, we have only defined the prompt and LLM as separate piece of a code. They don't do anything until we connect these both, okay, and execute them. To make them work, basically to make this piece of code to work, we need to run them in a specific order. First, the prompt should be executed or basically initialized and executed. And next, the LLM model needs to be initialized and executed. Okay. Because of the after the prompt has been initialized, then only the model will be able to use that prompt. Okay. So here we are seeing a sequence of steps. The step one prompt, step two LLM model, and step two is dependent on step one. Okay. This type of mechanism or this type of sequential execution of steps can be achieved using chain, or most probably called as LangChain expression language. Okay. When I say chain or LCL, it's not like it's 5 to 10 lines of code. It's just only a single line of code which will take care of this. Okay. Chain equal to step 1 followed by pipe symbol, step 2. Okay. So step 2 will be input intent analyst. So I'll add a pipe symbol before that. And the name of step 1 will be a chat prompt template function. So it will be user input formatter. Okay. In case if we have more steps, then the format will be step 3, step 4, pipeline, so on till step n. Okay. So now I have sequentially arranged the steps. The next function which we need to call is invoke. Chain.invoke will make sure all the steps are sequentially executed. And the input to this will be input query, because the chat prompt template is expecting an input query and we have provided it dynamic. So on runtime, the value will be populated. We need to provide input query as a key followed by value. I will I want to post about India 2026 World Cup win in LinkedIn and Twitter. And I would execute this cell. So it has provided as the output content where LinkedIn equal to true, Twitter is true, and Instagram as false, and also the user message is separate. Now, I want it to convert as a function because we need to build the input node, correct? So, what I'm building, I'll copy this entire piece of code here and I will change it to this particular line. Okay, because as it I will be utilizing it as a function. I don't want it to be hard coded. Instead, I want it to be user value. Okay. So I will give here input query equal to input. I'll call it as a user input and input of then enter the request. And I'll use this chain.invoke to use the user input. Let's give the name what we have initially give input node. So I will be saying it as input node. Okay. Then yes. Okay. Now, so we have only created a plain function. Okay. Now I need to create this LinkedIn content generator, Insta content generator node, Twitter content generator node, the planner node, aggregator node, and okay. For this, we will be using LangGraph. So before we jump into a LangGraph and write a code, let's understand the concept of a LangGraph. Now, as chain is a sequential order execution, and the next step is dependent on the previous step, correct? If we go back to our drawing board, if we see here, we can't use chain directly. Input node will pass the content to planner node. Planner node then decide which node to be executed. Okay. And then there is an aggregator node, then there is an end node. So basically from start to end, multiple tasks happen or multiple nodes will execute. Maybe one node is not dependent on other node because here the LinkedIn and Insta are not dependent on each other, although they are dependent on the planner node. So here input node will decide the intent and then pass it to the planner node. Planner node will check the platforms and then basically pass it to the individual content nodes. But does the content node are dependent on each other? Yes, they are dependent on planner node, but they are not dependent on each other. These can be executed parallelly. So as we will not be able to achieve this using chain, or like what we are trying to do can be achieved by using LangGraph. Okay. So basically, LangGraph is use it for a in a concept of the cyclic graph, correct? Because from step A I want to go to step B, but from step B I want to go to step D. From step D I want to go to step C. From step C I come back to step B and then I go to step B, or then I might come to an end. Okay, so this type of the cyclic graph or the cyclic execution or the in like multiple execution of different nodes which are not dependent on each other, but they maintain state across all the steps. Okay. When I say they maintain state across all these steps, even the LinkedIn content generator will be aware of what has been executed in the input node. Okay. The aggregator will be aware of what has been executed on the previous nodes. Okay. So the state is maintained across all the nodes. That is why we will be using LangGraph here. Input node will give us structured output. Okay. Now the output of the input node will be updated to state. State will be output of input node. This planner node will use the output of input node as an input to planner node. So here input will be output of input node via state. Now planner node will also generate some output, correct? Update the state. It will update the state with its output. Now, LinkedIn content generator will also have the input, correct? So it will use the output of input node and the planner node via state. Now, aggregator will also use some input, right? So aggregator will use the output of input node, planner node, and content generator nodes via state, and it update the output back to the state. Okay. So if you see across all the nodes, states are maintained or states are accessible. This is achieved via LangGraph code. Now, I need the platform detector, which will basically say LinkedIn true, etc. Then user input. Okay, what user has requested. So this too gets updated by the platform node, not platform node, input node. Correct. So basically, we need to create a class. I'll call it as a class input schema. Okay. And this can be created using type dict or a pydentic. Okay. So we will be using class to define the schema of the state. And what does this schema contains? Basically, what data will exist and what fields each node will be able to read and write. Okay. So what data will be exist? We'll have the platform detector data and the user input data. Correct. So basically, now I want this initially as platform checker. I'll call it as a platform checker, not detector. So what will be the data type of this? It can be list. It will be list basically. Input query. This will be string. Okay. So we need to import from typing import. Okay. And we'll also import annotate. Okay. So why do we use annotated? Why do we use annotated? Okay. Now, here I said output of input node can be updated by planner node. And it also can be updated by the any content generator nodes. Right. So when I update it, I don't want it to override the output which is generated by input node and planner node. Instead, I want to append it. Okay. This is where annotate comes into the play. When we declare this annotated, it will make sure the content on the platform, basically the content on this particular field, it will not get override. Okay. So I'll use annotated list add. So we need to import add as well. Okay. Now, so we do need different schemas. Okay. So we do need more fields or more uh, variables inside the input schema, but we will define it as further we go. So we do need LangGraph start, think, end. Okay. So we need to add it as part of the requirement text. So this should be an end step, but before we go, but I want it to be initially, so we know what we are building. Okay. Use graph equal to state graph. Use input schema here. Okay. Then we need to add edge. So then we need to add a node. So basically the node becomes input node. I'll call it as a platform detector node. So here it will be a function name, which we need to define. We have not defined it yet. Then let's copy paste it. What all nodes we might need. We will be needing, okay, like LinkedIn executor node, Twitter executor node, and then Instagram executor node. Okay, so we do need to define the function name, and then we might need a reducer, right? Aggregator node, basically. I'll call it as reducer node. Okay, initially we do need these nodes. Then basically it will be add edge. I'll explain what are nodes. So you do understand what are nodes, right? So these are nodes. Basically input and planner node. Input node is there. So input node is the platform detector node. Okay. I'll come to planner node, how we'll be using it. Then I have the LinkedIn executor node, Insta executor node, Twitter executor node. Then aggregator, I have given it as a reducer node. Okay. The edges are the connectivity. The black line here, the orange line. So these are edges. Okay. The first one will be start. Okay. Here, user goes to start. So start to input node will be connected. So, okay. Then what I'll be doing? I'll directly create this reducer node and okay. Let's define a platform detector node. So basically the function name and the node name can be same, or you can call node one anything. Okay, because this is a key and this is the value. The function name will be the value and this will be the hard coded key. Okay. Okay. The issue is the capital L. Okay. Yes, we are good. Now I'll define the node one. I'll call it as a definition and we will call it as the same platform detector node. Okay. Then state input scheme. Okay. State input schema. Yes. From the platform detector node, we will be calling the input node where we have already chained the template and the LLM model. Okay. Then this will be as input node. Okay. So here the input query will be passed by the graph. Okay. So this input query should be passed to input node. Correct? True. So instead of input query, let's maintain the same naming convention what we have given here. So we'll use this as a, I want to use it as an input query only. So let me change this input query. input query and input query. Good. So let me rerun it. Response equal to input node. I'll comment this all. We use platform node. We need to compile it. I don't want this to be here. I'll remove this. And when we use an input node, let's pass this. Okay. Okay. Say LinkedIn true, Instagram true, user message. So, but current content, I would just want to make sure that we receive it in proper JSON format. So what I'll be doing is like, I will add some formatting here. Okay. And then update our platform checker. Currently, I didn't update a platform checker yet. So just to make sure that I don't have extra spaces or anything. I've added these 3 lines of code to make sure that the response what we are getting is free of the junk spaces and everything. Okay, because different LLM might return us in different formats. So I just want to make sure that it is in sync with what we are expecting. So now I'll create platforms equal to, it will be LinkedIn, and then it will be Twitter, then it will be Instagram. I just need to import JSON as well. Platforms. Then I'll update platform checker. Okay. This will make sure it's updating the platform. Basically, this will make sure that it is updating the main state. We are done with this.